Alright, so we just got finished with our trig function graph. So we were graphing sine, cosine, and tangent. So now we're going to expand upon that, and we're going to start doing some transformations. And these can be a little difficult, but I'm going to try to make them as easy as I can. So if you look over here, we have like our general setup for each. So the only thing that really has changed from 11.1. 11.1, we were just dealing with something like this. It would be like A, which would be a number, times sine, B, which would be a number, times theta. Now, we're adding in this H portion and this K portion. So, we'll pretty much define what that means. So, we have phase shifts and vertical shifts. Phase shifts are like horizontal, so you may hear me say horizontal shift just because it makes more sense to me than phase shift, but I'll probably end up saying horizontal a lot. But if you see plus H, that means it's shifting to the left. So if we were looking at a coordinate plane, our point would move to the left. Now, if we have minus H in parentheses, then it's a shift to the right. So it would be moving this way to the right. And some examples of that. So if we had y is equal to sine of theta minus pi, that minus pi would be the same as minus h. So that is going to be h is pi. So it would be pi units to the right since it's minus. And then if we have y is equal to tangent of theta plus pi over 4, that's plus, so it's moving to the left, and it would move to the left pi over 4 units. All right, then we have vertical shifts. So vertical shifts move just like it sounds, vertically up or down. And these are a little bit easier just because you don't have to worry about the sign being different than you would expect it to be. Because like a minus shift, I always think that means go to the left, because the left is usually, like on a number line, the left is usually negative numbers, but it's kind of the opposite. Now on vertical shifts, it's just like you think it would be. So plus k is going to move up, and minus k is going to shift down. So if we had y is equal to tangent of theta plus 2, and notice that's not in parentheses, so that's an indicator that it's k and not h. H is going to be in parentheses, k is not going to be in parentheses. So plus 2, not in parentheses, is saying to shift 2 units up. So we would move our entire graph up 2 units. Now, another example is cosine of theta minus 4. So once again, it's not in parentheses, and it's minus, so that says go down 4 units. So that's really what you need to know for that. Now I'm going to try to show you, if you move your original point that we make, you can pretty much make your graph based upon that, and you don't have to do 2 graphs. So I think I told you before we were going to do 2 graphs, but I think we can get around that. If we absolutely have to do it, then we'll do it. So when you put it all together, here's how it would look. The only thing that's going to change is this trig function. It could be sine, cosine, or tangent, pretty much how we have over here. So you'll need to know those, and you'll need to make sure, like if you're not printing notes or anything, make sure to get those written down because you'll need those. All right. So whenever we graph these and we move our original point, we essentially create a new horizontal axis. So all the problems we've been doing look like this. They look like this problem here, and they're all lying on the x-axis. But whenever we shift this plus 4, we're essentially moving this entire thing up 4 units. Now our new horizontal axis is at y is equal to 4, and that's called the midline. So you create a new horizontal axis, and we call that the midline. And this just tells you where your line or where your graph is oscillating. That just means it's going in a wave like this. Now, like I said, these are a little bit easier than you would think they would be because the equation for that midline is y is equal to 4. So for instance, sine of theta was on the x-axis, which is y is equal to 0. So if we take that up 4, then our new equation for that line is y is equal to 4. So hopefully that part won't be too bad. All right, so now let's practice doing some of these. So here we're not doing any graphing, we're just describing what is happening. So you could do this a few different ways. I'll probably just go down the line here and look for each one. So the amplitude for sine comes from A. So what is A here? A would be 1/2. So our amplitude here is 1/2. Our period comes from whatever's multiplied in front of theta, so that would be B. And then we take B and we say 2 pi over B for sine. So that would be 2 pi over 3. So 2 pi over 3. Now the phase shift here, there's no parentheses in this, so there's no phase shift. So you could just say none, because there's no parentheses here. Now, if there were parentheses like in number 2, that's where the phase shift happens or the horizontal shift happens. But if there's no parentheses, that means that there's nothing going on here. There's no horizontal transformation. Now, the vertical shift comes from whatever's added or subtracted that's not in parentheses, so that would be -5. So -5 tells us to go down 5 units. So you could just say down, 5 or down 5. Now, that down 5 is going to create a new midline. So sine starts at the origin. So if we go down 5, our new midline would be at y is equal to -5. All right, let's look at number 2. So number 2, we have tangent here. So our amplitude for tangent is always undefined. Now our period comes from B still, except it changes a little bit. The period for tangent is pi over B. So B here is just what's ever multiplied in front of theta. And theta is in parentheses, but this 2 still multiplied right in front of theta. So 2 is B, so our period is pi over B. Now we do have a horizontal shift here, or a phase shift, because we have these parentheses here. Now if we go back up top, we have, let's see, plus 2 pi. So when we have a plus h shift, that means we're going to the left, however many units that is. So we have 2 pi, so we're going left 2 pi units. And then the vertical shift is just whatever's added or subtracted outside of the parentheses. So that's a +1, so that means we're going up 1. And tangent, the x-axis would essentially be the reference or the horizontal axis before we made our vertical shift. So after we make our vertical shift, it would be y is equal to +1. All right, so that's how you pretty much get down all of your shifts. Now, the way I'm going to show you how to do it is to pretty much get all of your shifts down and then create your graph, because I think it's easier to do that. We're only going to move 1 point, essentially, instead of doing an entire graph twice. I just think it's easier, but if we have to change it up, we'll change it up. So number 3, we have y is equal to sine times 2, and then in parentheses, we have y plus pi over 2. So let's just go through each of these here, and we'll just get down everything we need first. If you want to do it in a different order, you can, but that's going to be how I do it because I think it's easiest to do it that way. All right, so first of all, our amplitude for sine comes from A, which would be an understood 1 to be right here in front of sine. So the amplitude is 1. Now our period comes from B, and B for sine is 2. Then we would need to know what is, how do we find the period for sine, and that would be 2 pi over B. So here we would have 2 pi over 2, which would just give us pi. So our period here is pi. Now we need to look for any horizontal or phase shifts, and that comes from anything added or subtracted to theta in parentheses. So this has parentheses, and it's a plus pi over 2. And plus in parentheses means to go to the left. So we're going to go left pi over 2 units. Then notice here, you don't have anything added or subtracted outside of your parentheses. So this would be like saying +0. So that means nothing's happening here on the vertical axis. So there's no vertical shifts. So you would just say none. And that means that our midline is just the x-axis. So the x-axis is y is equal to 0. So our midline doesn't change. All right, so now let's look at graphing this. So for this, you have to do a bit of thinking. So if we were to start off graphing sine, the first thing we would do is put a point right here at the origin. Now, this graph is moving to the left pi over 2 units. So we need to move this point to the left pi over 2 units, and then we can just graph the rest of it. So instead of our point being at that purple point at the origin, it's going to move here to y is equal to, or to negative pi over 2, because that would be the same thing as going left pi over 2 units. So it would be right here. All right, now you can essentially get rid of your start point because there's no other shifts happening, and then you can just graph this like you normally would, except now we're starting at negative pi over 2 instead of the origin, so you can get rid of that. All right, so now if we want to graph this, we need to graph our amplitudes, just like we did before, and our amplitude is 1, so that tells us that y is equal to 1, we need a barrier, and y is equal to negative 1, we need a barrier. And then our graph's going to be somewhere in between those 2 points. So we're starting here, and then we're going to move to the right, or you could go to the left, but we need to know how far over we're moving to the right. So if you remember to do that, we take our period and we divide that by 4. We're essentially splitting it into 4 parts so that we can know where each point's going to be. So each point's going to be pi over 4 units away from each other. And when we graph this, since it's sine, we always start off, if we're going to the right, we always start off by going up. So we're going to go up to the top of our amplitude, and we're going to go over pi over 4 units, which would be right here. Then we're going to go down pi over 4 units, which would be right here, down and over. And then we would go back to our horizontal axis, and then we would go down again, and then we would go up again, up again. So essentially this is what our graph would look like. So this one was not too bad just because our phase shift was going left. The only time really that these get really like sucky is when you have to move it over to the left or right, your original start point, and then move it up or down. But if you take your original point and use that to help you graph it, it'll make life easy on you. All right, let's go to the next one. All right, so next we've got tangent. So we've got y is equal to 1/2 times tangent theta minus 3. So let's just go ahead and get down all of this information here. Then we'll look at actually graphing this. So tangent, the amplitude is always undefined. The period comes from b, which b here, there's nothing multiplied in front of theta, or at least nothing that we can see, but there's understood to be a 1 there. So in this case, to find the period, it's pi over b, which is just pi over 1, which is pi. So the period here is pi. All right, then our phase shift comes from whatever's in parentheses with theta. Now, if you notice, there's no parentheses here, so that means that there is no phase shift or horizontal shift. So this graph's only going to be moving up or down. Now, we have minus 3 not in parentheses, so anything added or subtracted not in parentheses is the vertical shift. So the vertical shift here would be minus 3 units, so that would be down 3 units. So we're going to go down 3. And that creates a new midline. So another way to look at this is our first midline, or our first horizontal axis, is always the y or the x-axis. And essentially we're taking that and moving it down 3. So now our new horizontal axis is right here at y is equal to negative 3. So that would give us y is equal to negative 3. So that is our new, that's our new horizontal axis. So now that is functioning pretty much like our x-axis was in all of the problems we did in the last unit. So if I were you, I would draw that new one there just for you to use as your new horizontal axis, but you don't have to, but you're going to see me do it. All right, so now we can go about shifting this, because we know if that midline is our new horizontal axis, our graph here, since it's not moving to the right or to the left, it's going to start at negative 3 on the y-axis, because that's essentially like the new start point. If it were up here, it would be on the origin, but now it's moved down to -3. All right, and then we need, let's see, the next thing we need for our tangent line is the asymptotes. And those asymptotes come from taking the period and dividing it by 2. So our asymptotes would be pi over 2 and all of the odd multiples of that. So we would have an asymptote here. We would have an asymptote here. And we would have one here, which we would have more, but that's all I'm making you do right now. All right, then we need our, we need to know how far we're going to go up and down from this original start point, and that comes from A. So A is 1/2, so we're going to go up 1/2 and down 1/2. Then we need to know how far we go to the right and to the left, and that comes from taking this asymptote, which was pi over 2, and dividing it by 2 again, so it'd be pi over 4. So essentially what we're going to do in this graph is we're going to go up 1/2 from this start point, and then we're going to go over pi over 4. So we go up here and over here. Then we would go down here over here. All right, now let's get rid of this and this. And our graph would look something like this. Oh, that's not what I want. Okay. Our graph would look something like that. And I can do that in another color too, just so you can see it. All right. All right, so then our next graph would start at pi, because that's our period, except now instead of starting on the x-axis, it's going to start down here on our midline, which is like our new horizontal axis. And then we're going to go up 1/2 and over pi over 4, so that'd be right here. Then we're going to go down 1/2 and over pi over 4, which would be about right here. So that's how our graph would look. All right, now I'm going to show you when you're when you have a phase shift. So those first two problems, on the first one we had a phase shift, and on the second one we had no phase shift and a vertical shift. So when you put it all together, it's pretty much when it gets to the most confusing. So we'll do that next, and we're going to use cosine for that. All right, so first let's get everything we need. Let's get our amplitude, period, phase shift, vertical shift, midline, and then we'll look at graphing this. So cosine, the amplitude comes from A, and A here would be 4. It's just 4 multiplied out in front. So our amplitude here is 4. Our period comes from B, and if you notice, there's nothing in front of B or in front of theta that's multiplied, so there's understood to be a 1 there. So our B here would be 1, and 2 pi over 1 would just be 2 pi. And 2 pi over B is how we find our period for cosine. All right, then our phase shift comes from whatever is added or subtracted in parentheses, and here we have a minus. So a minus tells us to go right, and we're going 3 pi over 4 units to the right. So when it's in parentheses, minus tells you right. So we're going right 3 pi over 4. Now we also have a vertical shift because we have -1 outside of our parentheses. So a minus that's not in parentheses tells you to go down, and we're going down 1 unit. So our vertical shift is going to be down 1 unit, which means our new midline is going to be at y is equal to -1. So this part here is our new x-axis, or our new horizontal axis. Now, our amplitude is usually what we do next. Here's what changes. This amplitude is no longer at y is equal to 4 because we changed our horizontal axis. Now it's going to be 4 units above this line and 4 units below this line. So you're going to start at this line and go 1, 2, 3, 4. So now your amplitude tells you to have a barrier at y is equal to 3 and y is equal to -3. Actually, no, it wouldn't. It'd be 1, 2, 3, 4. It'd be y is equal to 5. So our graph is going to fit somewhere in between here now, instead of it being all the way at 4, because we changed our horizontal axis. Now, the best way to do this is to go ahead and see where your point would be, where your first point would be. So cosine, the first point would be at the top of our amplitude, so that would be here. Now the next point, or the difference that's happening here, is this is going to the right 3 over 4 units, 3 pi over 4 units. We've already accounted for it going down. So if you go ahead and make your new line and then do your amplitudes, you already account for it moving down 1. But then we're going to have to shift this to the right 3 pi over 4 units. So now this is going to go to the right, and it would end up being right here. So we no longer need this point. This is our new point. This point here. So now we've taken this point and we've shifted it down 1, because it was originally supposed to start here, and we've shifted it down 1 and over 3 pi over 4 units, which would be right here. So now we can just graph this normal. So if we go to the right, we're going to start making our next points. Now when you're doing sine and cosine, to get those next points, you have to take your period and split it in 4 parts. So 2 pi over 4 is going to give you pi over 2. So this is going to go down back to our original, or back to our new midline, which is our new horizontal axis. So it's going to go all the way down to that, and it's going to go over pi over 2 units, which would be right here. Then we're going to keep going down, and we're going to go all the way down to the bottom of our amplitude. So we're going to go down and over pi over 4, or pi over 2 units again, and that would be right here. And then we would go back up pi over 2, or go up to the new midline, or the new horizontal axis, and then we would go over pi over 2. So it would look like this. So that's as complicated as these really get. We'll work some more in class, and we're probably going to split this up into a few days, just so we can do all of these together, so you can make sure you have these down correctly. But make sure you get these notes down, make sure you get these examples down, and that will be all for this video.